Hi, my name is Anwar, and today we're going to talk about recursion, which is an interesting way to solve complex computing problems. To keep things simple, I'll focus on three aspects of recursion. What is recursion? Why it is so valuable? And how do we implement it? So let's get started. Imagine you are dreaming inside your own dream. Let's implement. You can write a function called dream and try to convert into a self-replicating function by calling the function inside its own definition. However, there's a problem. It can go into infinite loop, which is undesirable. So let's convert it into a desirable form by including another thing which is called base case. How can we convert into a base case scenario? Because we need to have a stopping criteria. We need to stop that function and then it will take us to the base. Now, in more formal ways, when we use recursion, recursion is a way of problem solving in computer science where the complex computing problem could be broken down into a smaller subproblem. And then each subproblem and these sub-problems could be solved and conquered. Just like divide and conquer, where a complex problem is broken down into a smaller subproblem, and then these subproblems are conquered, and then they help us to solve the bigger problem. In computer science context, we can use a programming technique where we can use a recursive function which calls itself, and so that it can lead us to the base case with the simplest form. Why do we need it? In terms of repetitive jobs, we all know the computers are really good at. So they are really good in mathematical problem solving, especially if the nature is repetitive. It leads us to the discussion of loops and iterations. We have seen various examples where the loops and iterations really help us to repeat the pattern. However, there are some limitations attached to them. One limitation is if the stopping criteria becomes a bit complex and has conflicting criteria, then iteration may not be helpful. Similarly, some of the structures, if they look like tree-like structures, like a hierarchy, then probably in that case, iteration is not good. And also in terms of searching or backtracking, where iteration may not be good. You can see on your slide the example of it. Another intuition which we get from nature, because nature also tried to visualize the pattern in self-similar and evolving nature. We can see various pattern like spiral shapes where the complex problems could be solved by looking at the simplest version, what is the smallest possible pattern. And then if you expand upon it, you can actually try to understand their bigger version. In a similar way, we can implement them. So my favorite example to implement recursion is Fibonacci sequence. First of all, what it is. It's a sequence of numbers where each number is a sum of previous two numbers. Why it is so interesting? Because it's related to golden ratio, and it has a beautiful pattern which is attributed to the beauty in nature. And you can see where floral pattern and other things follow the golden ratio principle. So we can write a definition of the Fibonacci sequence by giving a recursive definition here. We can define the base cases, which are like if the value of n is 0 and 1. And then we have a case for n, where the n is greater than 2, equal or greater than 2. So in that way, we can write that function in terms of the same function. How it is related to the golden ratio, we can always find a golden ratio by dividing a number by its preceding number. And the Fibonacci sequence is attributed to a mathematician, Leonardo Spisa, from Italy. He was trying to solve the problem of rivalry breeding, so he used this example. But later on, it becomes really famous, and it's one of the examples which we use pretty much to understand the recursion. We can visualize it better, the Fibonacci sequence, if we can visualize in terms of a tree pattern. So you can see, like, we can break it down into a smaller chunks, and then each chunk could be better visualized and it could solve. In terms of implementation, we can write a function Fibonacci with an argument n, and help us to define in terms of, it's basically a similar translation of the mathematical definition here. You can see we can develop a base case scenario. These are the scenario where we want our function to return, and then we can write all the higher values returning to it by calling the function with the higher values. So you need two ingredients, one the base case and also the self-replicating or self-calling function. However, there's a warning. The warning is related to the efficiency. The recursive implementation of problem may not be the most efficient way of implementing them. If we compare it simply to iteration, we can see like iteration is much better in terms of both space and time complexity, especially for the higher values. Now, the question arises, then why do we need recursion if the iteration is able to? Again, we have to go back. Some of the problem may not be really well understood if we do a iterative version. Another thing is like recursion is more explainable. It is attributed to clarity and explainability. One example which I can give you from my own research, we are trying to find a machine learning explainability. For instance, when the social media post comes related to suicide ideation, if we want to classify them into suicidal and non-suicidal, we want our machine learning model with generally black boxes and have no idea how they are deciding. If we use a model like decision trees, we can visualize better like how do they decide. So that's the way we can visualize it better, and they're more explainable. So if I summarize what we have discussed today in terms of recursion, we defined what recursion is. It's a self-calling function, but the intuition behind is if we have a complex problem, we can break it down into a smaller problem and say like, we think in terms of the pattern which is repeating, and then we can visualize it better. So that helps in terms of explaining why I think this is the better way to learn recursion. We used three different examples. The first example was dream inside a dream. That is an analogy you will never forget. And the other thing is the interesting problem of Fibonacci series. You can see beautiful buildings all around and the floral patterns in nature, where you can find direct application of Fibonacci series and how we can find a recursive solution to that. And the third thing is like you see all evolving patterns in physics and in nature itself. We can see there is a concept of self-similarity and pattern recognition. So all these concepts really help us to understand how valuable the recursion is, and it helps us to understand this concept better. I hope you like this tutorial. Thank you.